So I was looking in the spec under GOLANG programming, so GOLANG spec, and then also effective Go, so GOLANG effective. And these are two really great places to check for this stuff. And I was looking for make, because there's make and then there's also new. And what was the mnemonic device I gave you to help remember new? What's new do? I didn't give you a mnemonic device, did I? I don't think we ever got to that presentation slide. So there's make and new. And new, here's the mnemonic device for new. I got a new dog, it's a pointer, and I named him 0. I got a new dog, it's a pointer, and I named him 0. So if you use new, you're going to get a pointer to whatever you use new for, right? And it's going to be set to the 0 value. I got a new dog, right? It's a pointer, and I named him 0. If you use make, when do you use make? Well, make is like something has to occur in the background. And so here's an example of making a slice of ints, okay? Right there. And so something has to occur in the background to make that. And what's occurring in the background is beneath every slice, there's an underlying array. And so this says length of 10, capacity 100. The underlying array has a capacity of 100. So I could keep growing this without having to recreate a new array. For performance, if you know you've got to process 3,647 pixels and you're going to be sticking those into a slice, right? Whoops. Then make this 3,647, the underlying array, 3,647 in capacity. That way you don't have to have the expense of recreating a new array, much less not specifying it and having to create a new array when you hit 2, when you hit 4, when you hit 8, when you hit 16, right? So the point being, like we were looking at Tuesday, like like how do we tell if something's a reference type or not a reference type? And then we were taking addresses and referencing and dereferencing. And it says here in effective Go under make, the reason for the distinction is that these 3 types represent under the covers references to data structures that must be initialized before use. So they're references to underlying data structures. What are the 3 types? Slices, maps, and channels. So the built-in function make serves a purpose different from new. It creates slices, maps, and channels only. Right? So those are reference types that have an underlying data structure. In the Go blog, if you chose to read about maps, you would see that the underlying data structure is a hash table. Right? Interesting. So, so the main thing that I wanted to point out there is that slices, maps, and channels, sorry for the stutter, the slow, slice, maps, and channels are reference types. So the programming challenge for you is to prove that. Oh man, I gotta lay off the cigarettes. Wait a minute, I don't smoke. I just live in Fresno. So I did this, we were looking at that stuff, and under, here's new versus make, so you can play with that, look at that, but there's which one was I doing it under? Just one sec, I gotta like get the water out of my eyes, I can't even see straight and blow my nose, hold on. Turned away so you guys wouldn't look at me, but then the grill's sitting right there. Gotta watch all the nose blowing action. So I don't know. Where did I put it? I'm going to pause this video while I find it. So it's in 19, under GOLANG training, 19, new make. No, sorry, 21, functions. 26, passing args. Right? So when I pass it into a function and I change it in the function, does it change it, the original one, meaning it passed the reference already versus it just passed a copy, right? Or is it, changing the function and it doesn't affect it? So we saw this one, right? Right here, where we have an int, age 44, and I pass that in here. This gets a copy of it. it prints out 44. I change it to 24, and then I come back here after the function, and it's still 44, because this is not a reference. That's a primitive type. It's a primitive type, which means it's not mutable. I think that's what primitive means. Daniel, is that your understanding of primitive, Mikey? I always like to try to find the precision with these programming terms so that I use the right language when talking about languages. Pretty sure that's what primitive means. Versus like, non-primitive is more advanced, also like an object though, right? So int's not a reference type. Here we have string, which has an underlying array. I believe it's an array. It's a slice of bytes, and then beneath the slice of bytes is an array, right? And strings are not mutable, so they're also primitives. Let's look up primitive to make sure that primitive in programming. And we saw this in one of them. A variable's data type determines the value it may contain plus the options that may be performed on it. In addition to int, the Java programming language supports 7 other primitive data types. A primitive type is predefined by the language and is named by a reserved keyword. So they say it's just predefined by the language and named by a reserved keyword. That's what they call primitive. But I also think it means it's not mutable. So here's a programming language. Primitives are the simplest elements available. So it's the smallest unit of processing, right? As opposed to more complex data types like a struct is built of other types. A primitive int's not built of anything. Int is an int, right? A struct is built of ints, strings, a whole bunch of fields. So I'm not sure if I have the right word for talking about whether or not something's mutable. Because here we did it with a string. And then I did it with a map and a slice. That's all I could do it with. I can't do channel. It's map, slice, and channel to prove the reference types. So I want you, and at some of these places we used, right? We used addresses. So we took an address, passed the address in, right? Oh, this one didn't pass the address in. We're just looking at the address. But then here, didn't pass the address in. Let me show you passing a string with, oh, this is it. So here I passed an address, and this is part of the type. That's part of the type right there, star string. It's a pointer to a string. That is a type. This is an operator. It's an operator, like plus, minus, right? And it's saying dereference that. So here I'm printing the value, and the value is the address. So go is always passed by value. The value I'm passing might be an address, or it could be an actual value, like it's an int. I'm passing that value in, and it makes a copy of it. So here I'm passing an address in, and then I dereference it, and it shows me the value. So this is the dereference right here. Show me the value at that address. So it's almost like, they're two different things. This is a type, right? That star right there is part of the type. It's not separate. It's a type. But when you have an address, you could say, show me the value. When you have a value, you could say, show me the address. Okay? So use this to prove that pointers, that maps and slices, and I got to change the wording on this, but maps and slices are reference types. So here's the slice. So you could just copy that. But you also now need to prove it with a map. And the reason you copy that is because I was doing it wrong. I was using append, which I still don't totally understand, but I guess it creates a new slice or array or something. But if you do it this way, it proves it. So that proves, like you can see here, I start out with a slice, and then I print it, in which case, let's run it. Wow, I all of a sudden sounded really sick. And by the way, you guys are learning the best, the most amazing programming language that exists in the world today. And that's because I know every other language thoroughly and completely, and I could definitively say that. I'm just joking. But I really think that this is the best programming language in existence in the world today. It's amazing. like created by geniuses, created by one of the best software engineering firms ever. I know it's a lot of hyperbole, but like those are awesome credentials, right?
So why isn't it installable if that's the case? People don't understand it?
Do you know?
I think it is a black diamond run. I think maybe the name branding on it isn't the best. If I had branded this, I would have called it C4. It's the fourth iteration, the C programming language, and C4 has really good connotations, right? Like you want to blow stuff up,
C4.
you need some C4. You really want to get stuff done, you need some C4. Go is okay. It fits more with Python Node, a current trend in sort of making programming languages sound fun. Go for con, go for icon,
Go for Google.
go for Google, right? So that stuff all makes sense. I would have called it C4 because if it's in the C family, which it is, then calling it C4 automatically means this is the next big thing. Because C, C++, C Sharp, all big. C4, next
Go
big
says
thing.
Fresh start.
Hmm?
Go makes it sound like it's a fresh start, something new.
But also a fresh start. You couldn't call it D because that just sounds like you didn't do well. C somehow has transcended that already. There was a B programming language. I imagine there was an A programming language. Lack of creativity.
I would say assembly is A.
Assembly's A. All right. So now we need to go into functions. I think that's 21. And then go into 26. And then go into 12. It's firing up. So when I first print this, I get that. Oh man. And then when I print it here, I get that. And when I print it here, I get that. So it proves it's a reference type because I was able to pass an n. This gets it's passed by value, but then this makes its own copy. What it made a copy of was the address. So it has the address, right? And then it changes it, and when I come back up here, it's been changed, even though these are different scopes. And two addresses pointing to the same place, like, X is one variable. I wonder if I did this, what we'd see. Nothing. Did it not save? No, it's just the address in front of that. It doesn't actually show me that. All right, so that's how you'd prove a slice is a reference type. I want you to prove a map's a reference type. And I also want you to retype this one so you get the muscle memory. Go.